I just wanted to quickly introduce myself too, for those who don't know me. I came to Canada in 2008. I'm originally from Iran. I did my PhD here at University of Toronto on experimental quantum computing. Then I went to University of Oxford, same area, and did a 2-year research position. Then I left academia and started at Royal Bank of Canada as a data scientist first, then a senior manager, their product lead. I was there for 3 years. And in 2019, I, along with Xiang, founded Aggregate Intellect that I just described. Okay, so I'm going to move on to the actual topic of the night, which is AI products and how to build them. But I would like to establish some principles. Like, these are things that are going to be important in almost all the topics that we're going to go through. So let's do that. So the very first one is that when you're talking about products, it usually doesn't involve you sitting in a corner and developing, code or model or whatever. Building products requires you to talk to people, and a lot of it. Like, you almost have to talk to people every day to understand what problems they have and how you can solve it using, any solution that you're offering. So if you're not comfortable with that, tough, you have to figure out a way to do it. The second thing is that when you talk to people, it's very important to ask them questions that are not leading. Like, if you go to anyone and say, oh, I have this idea about this new app that I want to build, do you like it? Everyone is going to say yes. So you have to be careful about how you design your questions in a way to tease out the real desires and intents that they have, how they feel about your idea. Next one is if you wake up one morning and think that you want to do an AI product, most probably you're starting at the wrong place. Usually you have to think about a problem that you want to solve and then go about solving that problem. And that might lead into an AI product. It might lead into a product and maybe an AI product. But that's what you really have to focus on. Like, what is the problem that you're trying to solve? Next one is sometimes as you're going through the steps, you might feel that you're stuck in a circle. And in most cases, you probably are stuck in a circle. So what you have to do in those cases is that you have to stop, you have to breathe, you have to write down what problem you're trying to solve with whatever you're doing in that circle. And most probably you have to go talk to people. A lot of the time, I have experienced this quite a bit, that, I'm dragging my legs, I'm dragging my feet, trying to figure out something. And I spend half an hour talking to Xiang, half an hour talking to our users. And I get, lots of ideas and breakthroughs. So this is extremely important, goes back to the first point, but something that is obvious in hindsight, but a lot of time we forget. Next, a lot of people sort of get emotional attachment to the solutions that they think first. That's a very bad idea. You should fall in love with the problem, they say usually, not the solution. The only thing that really lasts is the problem, not the solution. Solutions come and go. And the problem lasts until you solve it, obviously. And another big topic is, as you're thinking about the solution that you're going to apply to the problem, you always have to think about all the ethical gray zones that exist in your solution. And this one has been a big topic as we're dealing with COVID right now. There are lots of ideas of solutions that we can apply to this problem that we're all dealing with, but are they ethically right? And all the steps and components that we're going to include are going to be ethical. Obviously, that's a controversial topic, but everyone can have their opinion and know where the borders of the gray zone is. Nextly, let's say you found a problem that you like, you really learned about it, you validated the solution that you want to apply, and then is the only time that you can start thinking about a product. Like, you shouldn't start from the product at the beginning. This is sort of rephrasing of what I said earlier, but it's slightly more concretely. Lastly, one before last, iteration is the key. Like, you can't design a product, you can design a solution, right off the bat. You really have to start somewhere and iterate and iterate and iterate. A lot of you might be familiar with this concept of build, measure, learn, which is a very interesting concept, essentially saying you have to create something, you have to show it to people, measure their reaction, learn from their reaction, and then build it again. And keep doing that until you actually solve the problem. We're going to go into more details about that in a bit. And a big concept in this one is the idea of validation. So all along when you're building a product, like from the moment that the idea comes to you until the moment that you really deliver and scale and all that, all of the steps are really validation steps. If at any point you think that you have figured everything available, and there is nothing else that you can validate, you most probably are not thinking about things right. So that's also another concept that is very important and something that you have to remember. And lastly, you do need a success metric. You can't, otherwise you're just walking in the dark. People choose success metrics that are vanity, like, I don't know, if you're a startup, how many people do I have on my mailing list? How many people registered on my website, et cetera, how many, social media shoutouts did I get, et cetera. Or if I'm in a corporate, it could be, X and Y and Z. Executives are very happy with my progress, et cetera, et cetera. Or, I have made these many PowerPoint decks about this concept. These are all useless. What really matters fundamentally is usage and sales. Like, are people actually using what you built, and are they happy enough with it to pay? And if these are not happening, you're doing something wrong. So don't do things that just make you happy. Do things that actually matter. So again, you have to think about all of these all along. You can't ignore any of them. Again, like the intensity of how much you think about each of them will be different in different phases, but you can't really ignore any of these principles. All right, so since I emphasized that the validation is a big part of the story, I would like to also introduce a validation framework. Again, this is not the only framework that exists, but it's a framework that we use, and it is very powerful, I think, and very generalizable. So essentially, all that you're doing in the stages of product development is that you're going to do discovery. You're going to figure out what problem people have and how you can solve that problem. Then you come up with some sort of a solution, and you're going to have to do a short-term validation. In the short-term validation, the idea is that you're going to give them a version of the solution which is not perfect. It's going to be buggy. It's going to be imperfect. But it is something that solves the problem immediately. And the value of this is for you to see if you're completely off or if you're sort of on the right track. And once you have this validation, then you can go to a long-term validation, which means that you build the better version of what you built here, or a more complete version of that. And then, again, the idea here is to validate, because you build something and you want to start observing how people use it and what kind of value they're getting out of it. So as I said, validation is all over the place. So let's talk about a framework to do this. So the framework that we follow internally, and I can't stop talking about it, is you first have to write down what you want to do. If you don't know what you're trying to do, usually you end up working on things that don't matter. So as soon as you did that, the next step is write down what assumptions you have about this thing that you want to do. And obviously it is important because everything that we're doing at any stage are at best hypotheses and assumptions unless we actually validate. Next, you have to come up with a validation plan, because you might know roughly what you want to do. You might know what your assumptions are. But if you're not honest with yourself at the beginning and come up with a validation plan and a minimum success, then you could just retrospectively look at your assumptions and say, oh yes, my data confirms my assumption, which is cheating yourself, but that's something that we tend to do often. Next thing is obviously do the research, which is either talk to people, collect data, etc. Next is, sit down, analyze that data, and learn from it, and eventually repeat. It is very unlikely that you can do something like this in one go and get to the result that you wanted. So a lot of the time, when you get to this point and learn stuff, you have to use that and go back to modify what you wanted to do and do this all over again. It's useful to have this on a particular cadence, like you can have a weekly cadence, like every week you do all of this once, get to the end of it, repeat. This validation plan is a very important step. You have to design experiments that you're going to do. You have to figure out, based on the assumptions that you have to design experiments. And based on those experiments, you carry out your research and collect data to learn. And usually it is very useful if you can create artifacts, because it is usually difficult for people to imagine what you're describing. It's much easier if they see what you're describing. So these artifacts can be things like, in the discovery stage, could be, very rough, low finesse mockups. It could be just literally something that you draw on a piece of paper. Or, I often just, put up slides and start drawing shapes to explain ideas, and people, interact with these and provide feedback. But in the short-term validation phase, you want to have a steel thread of your solution, which means that a solution that is end-to-end, but it's not perfect. It's, absolute bare minimum. And eventually in the long-term solution, you want to have a better engineered solution. On the learn side, you're going to deal with different types of data, because the data that you collect in your research and learn from can come in different shapes. At the beginning, you're probably doing a lot of interviews in your discovery phase. So you will have a lot of qualitative data. So free format text that you have to dig into, find topics that people talked about. And the interesting thing about this is that you have to turn it into quantitative to be more measurable, because when you define your minimum success in your validation plan, it must be something quantitative. Like it can't be something like people like my idea. It has to be more like 7 out of 10 people say that this is a problem they have, or something like that. The next stage in short-term validation, the idea is to collect quantitative data. You might not be able to do it at larger scale, but still you should try to do quantitative data. And the whole point of having the steel thread is that it enables you to collect data. And that's the most valuable part of a steel thread, because it can help you collect data, hopefully programmatically, but also, at least you can use it to talk to people and see how they react to it. But when you get to the long-term validation, you should have thought about scalable ways to collect data. You have to set up all your analytics and data collection and user tracking and everything that you need to make sure that you're collecting the type of data that will enable you to validate the hypotheses that you have. So that's the framework that you can use. And as I mentioned earlier, this is applicable to any problem size. Like it can be from where you're trying to define the vision of your product all the way to, I don't know, what should the color of this button at this corner be? And obviously there are more sophisticated ways to apply all of this, like A/B testing, etc. But that's essentially the same thing, like, because even in A/B testing, you have to figure out what you're trying to do, what assumptions you have, what experiment you want to do, and how to collect data about it at scale. Next, I would like to introduce the so what framework. I'm pretty sure that it has other formal names, but that's what we call it internally. It's a pretty simple concept. So in the first stage of the previous slide, I talked about write down what you want and write down your assumptions. This is usually a very effective way that we have found. Again, that's not our idea, that's an idea out there. But you start by writing down what you want to do. Then you read that and ask yourself, so what? And write down the answer. And then read that answer and ask yourself, so what? And write down the answer. And you keep repeating this. And what this achieves is that progressively you get to the fundamental reason that you want to do something that you want to do. To put this concretely, I give you an example from a project that one of our teams did in a previous workshop. So their problem statement was, we want to build a leaf image classifier for formats. So that was, where they started. Like someday they woke up and they thought, that's what I want to build. But to make a case around this, we do this framework. So I would ask, okay, so you want to do this, so what? So their so what is that so that they can identify if so they're referring to the farmers, if their crop is infected based on the appearance of their leaves. So what? So that they can tackle the issue as soon as it appears and focus on the parts of the crop that are affected. So what? So that they can only apply pesticide to the parts. So you keep repeating this, and fundamentally at the bottom of it, you get to the point that says, I care about reducing their cost, reducing their chemical use, and sorry, there's one more. And I want to reduce cost, increase efficiency, and reduce environmental hazards. So fundamentally, this is the problem I want to solve. So given that I know that this is fundamentally the problem I want to solve, I can go back to this and think, is this the right solution? Is this still what I want to do? And I can keep repeating this until I get to a problem statement that actually makes sense. That's the problem that I want to solve. And again, this framework can be used anywhere. You can use it when you're interviewing people. Obviously, you shouldn't keep saying so what, because that sounds passive aggressive, but essentially that's what you're trying to get at. Like, you want to know fundamentally why they are doing things. And you can do it again for very large scale things like what is the vision of your product, what is the fundamental reason you want to build this product. And this can be used to write down your stories about why you're building this product so that you can communicate it to others. So both of these frameworks that I talked about are going to be foundation for a lot of things that we'll talk about. I published this crazy picture on social media, and this is a very comprehensive overview of what I'm going to talk about. But hopefully I'm going to go through it piece by piece. One thing that when I did this, one thing that immediately popped out to me was, a lot of the time data scientists only like to do, exploratory data analysis and modeling, like this little piece. But you can very clearly see that that's a very tiny piece of a much bigger picture. And that's a very, I guess, humbling realization that I had when I draw this picture. Anyway, let's get into it. So the first phase, as I said earlier, was discovery. So in this phase, you're trying to understand why you're doing what you're building and why you're building it. And more importantly, can you build it? So let's say you want to build a product. Again, that's usually the wrong place to start, but say that's eventually what you want to get into. And AI has a question mark because a lot of the time you don't need AI as part of your solution, but you could need it. So very, very high level, fundamentally, what you need is these three concepts. So you need an epic meaning, you need a business strategy, and you need a product strategy. And this is not only about startups, it is also applicable to corporates. Like, if you don't have the business backing for what you're doing, it's not going to work. If you don't have a plan for how you want to build that product, it's not going to work. If there is no fundamental desire to do it, it's not going to work. So regardless of where you're building the product, these are three concepts that you need to make sure you have. And epic meaning is something that you might know in other terms, like vision, mission, etc. But I like epic meaning because it sounds epic. And these have a bit of hierarchical relationship. Like, you always have to figure out your epic meaning first. Like, you have to know what you're doing and why you're doing it. That's like the most fundamental question that you have to answer first. Then you have to, if this product is part of a business, you have to understand what is the business strategy. So you want to solve this problem, but how can you do it as a business? And it is kind of embarrassing, but it took me about a year after I started the company to realize that starting a company is different from starting a business. But that's a very important realization, because I started backwards, and in hindsight, that was a mistake. I started from here. I thought, okay, I want to build a product. Then I had to think about a business. Then I had to think about an epic meaning for it. While it should have happened the other way around. And the realization of these, the way people usually talk about it is, this is the desirability factor, and viability factor, and feasibility factor. So these are things that in your discovery stage have to think about and establish, which will in turn eventually lead into these top layer. Like, you don't write down these initially. Like, these are things that you want to get into, but you have to start from these. So these are kind of obvious, right? So desirability is, are you working on a problem that people care about? Viability is, do they care about it enough that they would pay for it? And would they pay for it enough that you can sustain a business with it? And feasibility is, obviously, can you build it? So any of these factors might exist and the other ones might not, in which case you don't have a product. Normally, 2 out of 3 are present and the other one is weaker, which means that you can kind of compensate it. But if you have only one of these and the other 2 are absent, then you have a problem. And another important point here is that the hierarchy is less prominent here. There's a lot of back and forth among these. Like, if you find something that is desirable but not viable, you have to probably go back and change that. Same with feasibility. So let's go deeper in each of these. So first of all, desirability is, who needs this? What problem do they have? What are they doing it? What are they doing now? So, and again, this is something that you can only understand through talking to users. So first of all, you don't know who the user is, so you have to identify the user. You have to identify what problems they have, and you have to understand what they're doing now. So they might have a problem, but it might not be big enough that they care about solving it. So if they're not doing anything about a problem that you're trying to solve, that's a bad problem. Or at least the market is not ready for it. The next thing is viability. So here we're talking about numbers. How many people need it? What size is the problem? Like, is it a $5 kind of problem, or is it $5,000 kind of problem? How much are they willing to pay for it? Can you reach them? So you might know that there are a lot of people and they would pay a lot of money for it, but you have no way of reaching to them. So all of that is going to be useless. And obviously you have to know, sort of tied into this one, which is, what are they doing now, is the question of who else is solving their problem. So they might have a problem, they might be ready to pay for it, there might be a lot of them, but somebody else is already solving their problem sufficiently. So you have to take all of this into account to think if you have a viable business. And eventually you have to think about feasibility. And this one is an interesting one, because the feasible solution is not necessarily something that you build. A lot of the time you can buy the solution and integrate it into something else and provide it as your solution to the problem. Sometimes you can just simply partner with someone else who has the solution, and then you can offer it as a partnership. And sometimes you have to build it because there's no good solution to buy, there's no one good to partner with, or maybe those exist but they're not aligned with you. But I think the most fundamental idea here is that there are all these options available to you, and most probably what you end up building is going to have multiple components, some of which you buy, some of which you partner, some of which you build. But you have to be clear about what you're doing for each of those components. And for the parts that you decide to build, it might be everything, it might be a smaller part. You really have to figure out what the minimal set of features you need for this to be feasible, which again comes from all of this information that you have. Like, you really have to know what people want to know what kind of features your product has. And as I mentioned, talking to people has to happen everywhere, but it is very prominent here. Here, most of the work is market research. Like, you would be probably researching numbers about the markets, how they're changing, how big they are, etc. And this part is mostly a technology assessment. Like, you're looking at existing solutions, you're looking at existing potential partners, and you're looking at technologies that you can use to build your product. Next step is short-term validation of your idea. So let's say you've done everything right in the previous step, you identified a problem, you identified that there is a business, a strategy that can be sustainable potentially, and you identified that there is a strategy around building the product, which can be a combination of a few factors. And now you want to further validate that that's a good idea. So what you need, again, remember that we talked about it before, you need an artifact. And the artifact that you have to create is something that you create as soon as possible. Usually it should be something that you create in 1 to 2 weeks. If it is something that takes longer, that's usually a bad idea. You should probably rethink how you're going to do it. But let's say you've done your homework and you're sure that you need an AI product, or at least a product that is data-driven. So the very first step of it is data collection. Obviously, you have to collect a bunch of data related to the problem that you're trying to solve. It can come from different resources. You have to combine them and prepare them to use for your steel thread. The data collection step, it is important for all of the steps, but also the data collection, that you have to be careful that you don't spend a ton of time on this one, because you could really go deep and worry about a lot of different factors that might come into play. But at this point, remember that you're trying to spend a week or two building something that you can put out and see if people interact with it. So you collect your data, you do your exploratory data analysis. So at this point, you're validating if this data supports the hypotheses that you're trying to validate. If it doesn't, you have to go back here and change it. But assume that it does. So the next step is that you want to build a model. But hopefully here, you don't go overboard a lot of the time. I talk to people and they're like, I want to build an NLP model, or I want to do this, complex deep learning model. And they're thinking about that step even before, trying the simplest possible model. So usually at this stage, remember that you're trying to do something as quickly as possible, something as simple as possible. And the end purpose is not really modeling. The end purpose is enabling yourself to collect more data and validation. So, ideally, you want to go for the simplest possible model. It could be even rule-based. It could be simple statistics. It could be, the classical machine learning techniques. And, if you exhaust all of those, only then you would potentially go to deep learning models. And it is a very important thing to realize. A lot of people spend most of their time on this one, while they should really spend their time on building this quickly and getting validation from the users. Obviously, once you have the model, once you have the data, you approved it, you build a simple model around it. The next stage is to build this model, to prepare it, for deployment. You have to package this model, you have to deploy it, and you have to deliver it. So all of these are, what we commonly call ML ops, so machine learning operations. These are the steps that you go through to make your model and your data available to the end user. And this delivery can have different forms. It can be a UI. It can be just an API endpoint. It could be different ways, for example, Python packages or whatever is needed. But you have to make sure that you deliver it in a way that is available to your end user so that they can interact with it. Because at the end of the day, this is what you were looking for. You wanted to get feedback from the user. So you did all of this work so that you can get feedback. And once you get the feedback, you can ask yourself, did I solve the problem? And if you have, congratulations, but most probably you haven't. So you have to think about, what was wrong with my engineering? Is that where the problem is? So can I improve any of these steps? Next is, maybe the model wasn't good enough. Maybe I can change the model to be more accurate, to be faster, etc. Whatever is the metric. Or maybe the data was not the right data. So can I use different data sets? Can I combine the data in different ways? But at the end of the day, you do this iteration until the answer of this question is yes. And that's all that matters. Like fancier models don't matter. Bigger data sets don't matter. Fancier ways to deploy don't matter. At this point, all that matters is that you can do all of this as quickly as possible, put it in front of the user, and understand if this is solving their problem. Because if you're not solving their problem, in a week, you would know, and you would go back to your drawing board and figure it out again. But if you spend a month on this, like if you are using a complex deep learning model that takes 3 months to figure out and deploy, and then you end up, learning that it doesn't solve the business problem, the user's problem, then you wasted 3 months. So that's the short-term solution. Once you have it, you put it out, get feedback from the users. The next stage, assuming that the answer is finally yes after many repetitions, or rather iterations, you want to have a long-term plan, a long-term validation. So this is where you ended the last step. So what you have to do at this point, this can happen in parallel to the data collection, to the feedback collection from the users. And hopefully iteratively you can improve what you have and turn it into an engineered solution that is your long-term validation. And I want to emphasize again that this doesn't end. Like it keeps going on and on as the product matures over time. So you can do a lot of modifications, you can do a lot of improvements, but you also have to start thinking about a lot of factors that in the first iteration you didn't think about, but for a long-term solution you have to. For example, for the data collection, you have to think about, okay, so I'm going to use this as a long-term solution. Does the quality of the data good enough to support this long-term solution? Is it ethical to use this data? Like, am I using protected data elements? Is this data does this data create any sort of competitive advantage? And this is a very interesting point because almost nothing else in this process are things that are too difficult to achieve. Like all this, engineering process are things that are fairly known. All these modelings that you would do are fairly known models. Like it is very rare that you would come up with a model that is significantly different or an engineering process that is significantly different. So the only thing that could be potentially a competitive advantage is your data. And a lot of companies get really big because they have very unique data sets like Facebook, for example. And finally, obviously is the privacy. Like, are you stepping on anyone's privacy when you're using their data like the way you are? The next thing that you have to think about is your model. Obviously, we talked about the capacity of the model. Like we talked about how you should start from simple statistical methods to rule-based methods to simple machine learning methods, and then eventually deep learning. So you have to think about how much you want to increase the capacity and how much do you need to increase the capacity to improve the performance of your pipeline as much as possible. Another thing to think about is intellectual property. Like, are you using a model that you have the right license to do? Like a lot of machine learning models are obviously open source, but open source comes under lots of different licenses. So you have to pay attention to what the license allows you to do. If the license doesn't allow a commercial use, then you're out of luck. So you have to figure out a different way to do it. Obviously, you have to think about interpretability of the model. Like, are you using a model that is so complex that there is no good way to interpret results? But more importantly, is that necessary to know the interpretation? What is the risk of not knowing the interpretation? And in general, what is the risk of using that model in your business setting? And in terms of deployment, usually this deployment is sitting on some sort of an infrastructure. So you have to think about things like, is this a securing infrastructure? Can bad actors penetrate the system through the endpoints that I'm providing? Is the system, what are the availability requirements that the end user has? Like, does the end user just need to use this for half an hour a day, or does it need to be up 24/7? How can I control the access to the system? For example, if there are different types of users and they need different access levels, how can you set that up? Is the performance of the system on an engineering level, like all sorts of service level agreements, established and achieved? Finally, on the delivery side, do I have the right user interface and user experience? And this is a very important step because if you remember, one of the principles was talking a lot to the people, to the users. And if they can't understand how your UI works, and if your user experience is not desirable, they're not going to use it. They don't have to use your product in most cases. But two other very important points that usually people forget is, if this is something, let's say, if the delivery method is APIs, what are the requirements to integrate that as into the technology platforms that it needs to integrate into? And how can you make that as easy as possible for the users? But most importantly, the thing that is usually forgotten to be thought about from the very beginning is business integration. So usually, you are introducing this product, this technology, as part of a bigger business picture. Either it is in a corporate that has some sort of a business and your technology product is going to integrate into it, or you're a startup who's building a product, but your clients are businesses and they have their own ongoing business, and this needs to integrate into it somehow. But also, even on a small startup level, you have to be very clear about how this product contributes to your business. So there are a lot of things that you have to think about as you're designing and improving your system. And a lot of these factors might be deal breakers, which means that you can't use some of the things that you used. You have to go back and modify them over time. But eventually, the purpose is to come up with a pipeline that solves the user's problem, but also addresses all of these concerns in a way that is maintainable. And once you have that, you're still not done. There are a few things that you have to think about. Potentially, you have to iterate over a bunch of things again and again. Some of which are like, you have a pipeline, it is working, you're collecting data. Can you collect any type of data that helps you solve a bigger problem? So can you make, can you use your data to make another product that is also interesting for the user? Or can you collect data to solve even a bigger problem that the user has, where the problem that you just solved is a subset of that bigger problem? And this is, for example, can be very interesting in cases where you have to start from unsupervised problems because you don't have labels, but over time you can collect user data as implicit annotations and use that to do supervised methods that improve your performance and opens up the path to a lot of different problems. Well, I mean, at least solving those problems. The next important thing is, can users actually use your solution? And is it easy enough for them to do it? And if they can, would they continue using it? Like, they might get excited about it for a week, but would they use it every week? Because if they don't use it every week, you're out of luck. And if this happens, it's fairly late to realize it, but most probably you didn't either identify the right problem, or you didn't identify the right solution, or what you built does not really represent your solution. And the most important question of all is, given this product and integration into the business, can you use it to sustain a business? And again, this is a problem that exists in big corporates as well as startups. In big corporates, if you're a technology team, your funding is coming from somewhere, usually business. Would they continue funding you? Or if you're a small startup, your whole existence relies on that. Well, unless you're using investors' money for just sake of it, which is usually not the way to build successful businesses. Lastly, one topic that is tangential, but I think is very important to talk about, and I think the majority of companies that I've interacted with do this wrong, is, what team does it take to build something like this? Usually, companies hire based on what is hot in the market. For example, company A has hired data scientists. Oh my God, we should hire data scientists. So there's no, background thinking about it. While the right way to go about it is really to think about, your product strategy. That is obviously, as I mentioned before, comes from your ethic, meaning, and business strategy. So once you know what your product strategy is essentially, what are you going to build on what time scale according to what action plan. If you have that information, then you can probably draw up some set of conclusions like this. To support this, to build and support this product, what kind of architecture do you need? This could be this could be a technology architecture, but also simultaneously a business architecture and how it fits into the business. Based on that, you would know what your technology stack is, based on which you would know what the skill set of your team members would be, and eventually you can build your product team based on that set of skill set. Normally, these are the type of roles you would need, like a product manager, product designer, machine learning engineers, data scientists, data engineers, and if your delivery method is a UI, then UI developers. A lot of the teams that I have interacted with and talked to, they really focus on this. They don't focus on anything else. That's never going to work. They try to do various versions of this, like attaching a bunch of different people to each other that don't really match. It doesn't work. They try to create team without going through this procedure, and the team can't perform. Well, you kind of know why. So it is really a thoughtful and careful process to figure out what kind of a skill set you need and who's going to take these roles. And you kind of have to have all of these in a product team, because otherwise a piece is missing, and that's a big problem. Finally, I like to provide a list of a bunch of books that I have read or I'm planning to read, that are very interesting, I think, and everyone should read them. First one is The Mom Test. It's a very, very short book. I think you can even find a free PDF online. It teaches you how to ask questions that are not leading. Essentially, any questions. We talked about this slide at the beginning, but it's definitely a very interesting book to read. The thesis of the book is that if you can ask your questions about your idea from your mom, and your mom gives you her real opinion, then you succeed, because your mom is obviously very biased, and she always wants to support you. But if she really dislikes your idea, you have to design a question that she really tells you that she dislikes it, but in an implicit way, because she's never going to say it up front. Next one is Inspired. It is a very good product management book. Lots of great ideas, stuff focused on it. Like, none of these are really focused on AI specifically, but these will give you a lot of contextual information. The Innovator's Dilemma is a very famous book. A lot of you might have heard of it. Same with Lean Startups. A lot of the frameworks that I talked about are adapted from Lean methodologies. And there are two books that are not usually mentioned in the product set of books, but I really like them and I think everyone should read them. First one is The Theory of Fun. It's a book about game design. It's not a book about product design, but I think it is extremely important to read this theory to have an understanding of how users interact with, in this case, games, but you can generalize it to products in general. So an extremely interesting book to read. This is another book that I'm planning to read, called Design Justice. And the focus of the book is how can you do designs that are inclusive. And that's a big problem, because a lot of diversity and inclusion problems are because of the lack of good design. So the environment is designed in a way that is not inclusive. It doesn't allow for, a set of users to engage. And you all know many examples of that. And this, book provides a framework for how to do that by design, so that the product that you're creating doesn't end up with something that you created and then, inclusion comes to it as a, late attachment, like many companies do.